us have here example number 7. Okay, so for our example number 7, we have here this problem, and we have the diagram. Okay, so in this eye bolt, okay, so we are to determine the value of the f sub 2, where the f sub 2 should have a minimum magnitude, and we are also asked for the corresponding resultant force, which means we have to add the f sub 1 and the f sub 2. In order to solve that, the f sub r should be directed along the positive y-axis. Can you see it, class? This one. It should be along the positive x-axis. So they take note that our f sub r should be here. This f sub r. And then we are to determine the magnitude. So obviously, this is already our direction for f sub r, which is along the x-axis. So in this problem, we are to determine the magnitude, the angle of the f sub 2, as well as the magnitude of the resultant force. Okay, so the only given here is the value of our f sub 1, which is the 800 Newton. Okay, so if we isolate the figure, okay, so we'll have this one. Take note that this triangle was taken from the parallelogram drawn here. Okay, this is how to draw the parallelogram. So you'll have to make a parallel. You have to make a parallel. What do you call this? A parallel line here. This one. We should make parallel also here, there, and you'll have to make parallel there, okay, to make a parallelogram there. And from that, we have a resulting angle here. Take note that the angle here, class, is equal to the angle here, which is 60 degrees. Okay, so this is our f sub r, this is our theta, which is the direction of our f sub 2. So if we isolate that part, we'll have it like this. There. This is our f sub r, class. This is our f sub 1 and the f sub 2. Okay, so again, our target from here is to determine the magnitude of our f sub 2. Okay, magnitude, as well as the direction, which is with respect to the x-axis, and also the magnitude of the f sub r. Okay, so from here, we'll have first, our given is f sub 1, like I said, 800 newtons, as well as the direction of our f sub r. It should be directed along the positive x-axis. And from this, we are required to solve for the magnitude and the direction of the f sub 2 and for the magnitude of f sub r. Okay, let us start with the solution for the f sub 2. Now, to solve for the f sub 2, class, let us again take a look with the diagram. So the f sub 2 here is, as you can see, it is towards the x-axis, so it is touching the arrow of the f sub r. Now if we go back to the condition of the problem, our f sub 2 should be of a minimum magnitude, or it should have a minimum value. Now if we think the f sub 2 must be, or must have different values, it only means that f sub 2 can be more than this value, or it could be any value. Okay, but what we are looking here is the f sub 2 should have a minimum magnitude. Now if we analyze the triangle, okay, look at this triangle, or look at this situation. If our f sub 2 is right here, okay, this is our f sub 2. Originally, this is the position of our f sub 2. Can you see it, class? This one. But if we try to move it here, it's because, class, this is the location of our f sub r. Okay. Now, if this is our f sub r, and this will be our f sub 2, so the question is, if the f sub 2 minimum at that point, Now, if we try to relocate our f sub 2 right here, so what will happen? As you can see, the length or the magnitude of the f sub 2 also lessens, right? If you go further from the x-axis or go backward to the x-axis, the length of the f sub 2 lessens. As well as here, class, if we make it perpendicular, exactly perpendicular to the x-axis, which is at the angle of 90 degrees, it will be also a little bit shorter. Now, take a look if our angle, okay, will be lesser than 90. What happens to your f sub 2? What can you notice? Does it become shorter or longer? If you compare the length of the magnitude of f sub 2 here at 90 degrees compared here and here, which is shorter? Is it in the middle, the left, or on the right? If you can observe, class, the only part where it is shorter is at an angle which is 90 degrees. So which means we can say that at 90 degrees, okay, our f sub 2 will have the minimum magnitude. Therefore, the answer for the direction of our f sub 2 is at 90 degrees. Okay, that's already the answer, or that's the direction of our f sub 2. Now, how about for the magnitude? For the magnitude, class, take note that right now we have already our triangle. Earlier it looks like this, right? Sorry. Earlier it looks like this. This one. The triangle looks like this. But since our f sub 2 is now located at the perpendicular or at the 90 degrees, our right triangle becomes a right triangle already. Okay? It becomes right triangle and this one here. Okay? So just focus on this triangle here at the blue sides. There. So from this figure, okay, how are we going to solve for the magnitude of the f sub 2? Okay, the only way that we can do that, class, is by trigonometry. Okay, we will apply trigonometry. So since this is a right triangle, so we can use the SOHCAHTOA. Okay, can you recall SOHCAHTOA? So represents sine, opposite over hypotenuse. Ka represents cosine, adjacent over hypotenuse, while the TOA is for tangent, opposite over adjacent. Now, what do you think? In this situation, our target is what again? Our target is f sub 2. Okay? Our given is f sub 1. F sub 1, as you can see here, is the hypotenuse of our right triangle. So, take note, hypotenuse. So, let us focus this one and this one. So, between sine and cosine, what do you think is the appropriate formula? Okay. Again, f sub 2 is what of our given angle? Because we will focus, class, on our angle. Okay? What is f sub 2 of 60 degrees? Is it opposite or is it adjacent? Obviously, it is opposite. F sub 2 is opposite of our angle. So therefore, what trigonometric identity should we use in here? We will use the SOH, or the sine. And the formula for that is sine theta is equal to opposite over hypotenuse. Now, substituting, class, our angle is, like I said, 60, while the opposite side is the f sub 2, and your hypotenuse is 800 Newton. So if you cross multiply that to solve for the magnitude of the f sub 2, we'll have f sub 2 is 800 sine 60. So using your calculator, class, kindly encode, and the value of f sub 2 will be 692.820 newtons. Okay, that's the answer already. So that's the second required that we have already solved. Now for the last unknown, or for the last required, which is for the magnitude of the f sub r. Okay, so for the f sub r, class, it is right here at the adjacent side of the triangle. So still using the right triangle, what do you think is the appropriate trigonometric identity should be applied in here. Okay, involving what again? Involving the hypotenuse and the adjacent side. So obviously it will be the cosine or the ka. So the formula for this is cosine theta adjacent over the hypotenuse. So substituting class, still the same angle, which is 60. So cosine of 60 is equal to the adjacent side is f sub r and the hypotenuse is 800. So cross multiplying, we'll have 800 cosine 60, and using your calculator, the value will then be 400 newtons. So there you go, class, the values of the f sub 2 as well as its direction, and here you go, the magnitude of the f sub r. And that's the solution for example number 7.